Hey guys, this video will give you a brief introduction on EE542 Laboratory 9. So for this lab, I will first show you how to play with the Termux application on our phone. So I have already installed a SSH server on my phone set, so now I can do all the instructions on this on my laptop. So I'm currently using this command to connect with my phone set Termux, and I input the password. Oh, sorry. Yeah, that's it. And I can also install ZSH, which is another terminal application runs on Termux. So I can now use this command to show you the sensor list, which is Termux sensor -L, and that's the sensors list. And the next command is Termux sensor -A to show you all the running result, and Control C to disrupt it, and I can run all of the sensor and show you the result for just one time by adding -N and 1, and that's the result. And for the ambient light sensor, I'm using this one. You can see, which should be this one, ROHM underscore BU such and such. I can use this one, so I can run yes, I can show you the result of this sensor. It's stuck out of no reason sometimes. Yeah, that's the result. So currently the light value is 49 points such and such, and if I shade the light sensor, you will get a rather low value, which is near to 0. Yeah, you can see. And once I open another light, it will become a bigger value. You can see it now. So it got dust. Also, well, I don't know the reason, but let me try. I think it is because I'm currently uploading all the data from the other sensors to the Node-RED, and I cannot call the sensors multiple times in the meanwhile. So I'll skip this step, and I will show you the next step. Anyway, I will show you these steps later. You can see the result in the Thingsboard dashboard, and I set up the Node-RED on my PC side, which is here, and I'm currently running it. It's running now, and I will show you the result. A second. It's here. This is run on my PC side, and I have two HTTP requests. This one is for the Thingsboard here, and this one, the lower one, is for the Amazon AWS. This one is for the AWS, and I have two flows because they need different formats of the data. I will show later. And the next step is to set up the Node-RED on my phone side, which is here. It's running now as well. And how should we observe the data from my phone? We can observe it. You can see here. We can see it on the AWS IoT, which is here. Oh, 1 second. Yeah, that's it. Yeah, it has been already uploaded. Because we can see so many numbers here, so many values here, because I'm currently uploading the data from 5 sensors in my phone. So the sensors is yes, we can see that in the red node at the phone side, which is here. I'm currently running this command constantly, and it will upload the ambient light data from the ambient light sensor and accelerator sensor, magnetometer, and gyroscope, and gravity. And for the verification purpose, I use gravity sensor and accelerator sensor in the same time. So the value of those two sensors should be rather similar to each other. And I send the HTTP request to the this is the IP address of my laptop. I send all of the data from my phone to the PC side, and then for the PC side, I read the HTTP. I use the HTTP listener to read the data, and then I format the data here. Just the code. Because I'm currently using 5 groups of data, and which is what I just showed you. And I added timestamp. And for the AWS side, I use a string. I use string like this. Actually, this JSON.string file is not necessary. I just need to upload the string to the AWS and do the processing on the AWS Lambda function. But for the Thingsboard side, which is here, for the Thingsboard side, the data format is standardized, and I format the data here. I format the data into JSON format and JSON string, and I upload this JSON string to the Thingsboard. And at the Thingsboard here, at the device here, I can try to subscribe all the data, which is here. 1 second, which is here. I can subscribe all the data. You can see all the results here. There's so many of them, right? And I try to add them, show on the widget, and choose charts and add them to the dashboard. I add it to the dashboard, and the same thing for the other values, and then we can go to the dashboard. We can check each of the graphs. Yes, that's it. This is the magnetic sensors, and we can see we can see all the data in one dashboard. Yeah, you can see that for the gravity X and the accelerate X, they are rather similar, right? So the but they are from different sensors, so the results should be correct and valid, right? And this is the geo X, and once I rotate my phone, you can see maybe it will quiver like this. Yes, and this one is for the light sensor, and once I shade the ambient light, it will show. The value will show, but it will take some time to show the result. and then I light the sensor and will go up again. With jobs, I don't know the reason that there's no data now. Let's check the oh, I need to deploy it again, sorry. And we can see the data later in just a second. Sorry, I don't know the reason. Let me check. Oh, I can receive the data again, but I don't know the reason why I can't receive it here. Let me check it here. The device. Well, this dashboard is stuck sometime. Sorry, I'm not sure whether I still have the connection to the internet, because the network itself is not stable. But this one is for the Thingsboard, right? So I log out. Oh, it's stuck. It's stuck. This panel stuck. So I think I have to go to the AWS EC2. And check what happened here. Let me shut it down. Actually, I don't know the reason. But you can see here the Thingsboard is stuck. Actually, that EC2 virtual machine is stuck. I cannot use SSH to control this. And 1 second, let me show you the next step. Oh, what's... Oh. Okay, so the following step is not related to the previous one. So you can see that the next step is to redirect our stream to the S3 bucket. And we use something we use something like this. We use something we set up a S3 data bucket, and we set up a stream file host, and then we can get all of the data stream from the IoT panel to this S3 bucket. You can see here those are all of the data, and each one is rather big, something like this. We can download it, and we can do the preview. Oh my. Yeah, it's something like this. Those are the data from the sensors, 5 sensors, and let me check whether I have already started EC2. I cannot connect to that virtual machine out of no reason. Suddenly. But you have already seen the result, right? Okay, let's skip that step and move on to step 9. And we did such steps, and we then select everything from the IoT database, and you have already seen the result inside the S3 bucket, which is here. Those are the result uploaded from the Firehose stream Firehose. You can see. And it will be uploaded every 2 minutes. And the next step is to format our data and add a timestamp, and to process those data with a Lambda function. We set up a Lambda function here, and we add a trigger of S3. That means that once a new data is generated and uploaded to the S3 bucket, this function will be called. You can see here the trigger is this function, which is called Lambda handler. It will have an event, and we can use the event to get the bucket and get the value we uploaded, and we already have a context which is useless for this simple function, and we can get the okay, I will show you the code here inside the VS Code. And we can get all of the data that is responded from the S3 data bucket from this HTTP request, and we process the data by splitting the whole string into several values, which are stored in an array, and we then calculate the average value, the medians, and the standard deviation. And we, per the requirement of this, we also calculate actually we use the average minus 3 standard deviation, and you see it's here. We minus 3 and minus 2 and minus 1, we use those values to multiply with deviation, and added this value to the average value instead of the median value, and then we output all of the results. And finally we output the start data and the end data of this average value and the median value, which you can see here. You can observe the result with the monitor function, and the output result is actually here, and you can see that this is the response body. Sorry, this is not the this is the response. This is the whole response, and we get the body with this is body, and we need to use body.read function to get the content of the body. So and we calculate the sum value, which has 13 values. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, right? So it has 13 values, which are from the 5 sensors. Where you can see here, we uploaded the values from the those 13 sensors, and we also calculated the average value, which also has 13 values, and the medians, and the standard deviation, and the start data and data, and this is the average value plus or minus 1, 2, or 3 times the standard deviation. In each array you can see 6 values, and those are 13 groups. Those are 13 groups, and in each group you can see there are 6 values, and it makes sense, right? So for example, for the first one, you can see the sum is of it makes no sense, because it doesn't have any meaning, right? But the average value, which is the first one, you can see this is the ambient light. This is from the ambient light sensor, and this is ambient light value, and this is a median of the ambient light value. You can observe those values. It makes sense. And this for the main part of the over Lab9. And let me check whether I can still connect to the EC2, but I'm not sure. Yeah, I can connect it now. So I'll start the Thingsboard again and show you the result. It was stuck out of no reason, right? So I start this, and I go to the Thingsboard page. Where is that? Yeah, this one. Oh, it works again, right? Oh, thankfully everything is here. Oh, thankfully. And I open the dashboard. Hopefully, you can see the data again. And I will light my phone so you can see this light sensor has a bigger value now. Yeah, that's it. And yeah, you just see it. It didn't work out of no reason. And the last step is to answer the question, which is here. Sorry, but I'm really tired. And the questions are to show the architecture to process the machine learning. And as you know, the machine learning has two parts. The first of the two is to do the backward propagation, which is to train the neural network, and the second part of it is to do the we should call it forward propagation, which is to predict the result. And oh, sorry. And we have to first always use our IoT device, which is actually our Android phone here, to constantly upload upload the data from the sensors to where to maybe a server, a local server. And actually, we think since we can directly run everything on our laptop, and what if our laptop is installed with a Linux system on it? Actually, I think we can run everything on our Android phone, and yeah, we can omit this the second step. Let me try whether okay. We can omit this PC step, and we can directly upload everything to the S3 bucket. And of course, there may be some processing, necessary processing for the uploading, for the data uploaded, as you have already seen here in the Node-RED. And oh, by the way, I will show you the result that I run this command directly in a command line, but I'm not sure whether it will stuck again. Anyway, I'll show you that. Yeah, we got the result, right? We have 13 values. You can see here there's 3 values, 6 and 9 and 12, and this is the last one, which is the 13 values. Right, we have 13 values, and as I have said, and then after after I upload all the data from the IoT machine to the PC or the AWS or anyway, finally we just need to process all of the values to the S3 bucket, so that we can read the value from the S3 bucket with the lambda function, as you can see here. After we upload the data generated at the IoT set, we can upload everything to the S3 bucket. And now in our S3 bucket we have many data records, right? So this is a queue. And this S3 bucket, you can see this is the first S3 bucket. We actually need two S3 buckets in total. So the first S3 bucket is used to store the data, and we have to set up a lambda function, as I showed you. I think it should be here. Second. This is the lambda 3 bucket, and oh yeah, we need to set up a lambda function, and we need to set up a data trigger, which is the lambda, which is the S3, right? We need to choose the S3 here and choose our data bucket. Choose this data bucket and set the put event, and that's it. And the next step is to process those data. And for this lambda function, we need to do the backward propagation for the model, we use the data to update our uploaded to update our model. So we have to use another S3 bucket to store our machine learning model. So every time this Lambda function is triggered by the new data uploaded to the S3 bucket 1, we will try to read the previously stored model from the second S3 bucket. We read that model and to tell whether currently I need to train our neural network or whether we need to predict something. So if we want to train our neural network, we just need to do the 2 steps. The first step is to trigger by the first S3 data bucket, and we may call this this second S3 bucket, which is a model bucket. We read the model. We use the parameters. Actually, we read the parameters from that model and do the backward propagation for once. And once we have a new a set of parameters which are updated by the new values, and we can we need to store the parameters, actually the hyperparameters, as you know, to store them into the same S3 bucket again. So next time when we read the model from the second S3 bucket, we will have an updated set of parameters, right? So so the next step is to store the trained model. Actually, update the model to the second S3, which is those are the same one. You can see the second S3 buckets, and actually in this process, if we don't want to use, you can see in the whole process, so only step that we need to use an EC2 virtual machine is to monitor everything on the Thingsboard panel, right? So this is the only step that the EC2 virtual machine is involved. So actually we can get rid of the EC2 virtual machine, and we can just deploy our Lambda function, and everything is all set, right? So everything is just there, and it will be automatically called once I gathered data from our mobile sensors and uploaded them to the S3 bucket, and everything is set, and then the model will be updated automatically. And if we want to predict something, which is the second part here, which is the second part, if we want to use a model to predict something, to do the forward propagation, we can use the same Lambda function. Actually, we can use the same Lambda function, or else we can also set another Lambda function here, and to read the updated model, to read the updated hyperparameters, and to set the data read from the sensors as input, and do the prediction, and then we get the output, and we can do with the output whatever we want, right? So this is the answer to those questions. Yeah, and I think that's the all part. Then let me check whether there's something I didn't show you. Yeah, this is to configure an EC2 virtual machine at AWS. This is nothing. This is nothing. Oh, this is the tutorials. Also tutorials. Okay. Oh, let me try again whether I tilt my phone. I tilt my phone now, so I want you to see that, yeah, the data changes here, right? because I tilt my phone. I rotate my phone. Yeah, and I put it down on my desk again, so you can see the data changes again. Yes. And yeah, this is the stream fire hose. And it is always generating new data. We can subscribe a topic here to see the raw data uploaded from the Node-RED with, oh my god, with this HTTP request, with the upper one. And that's it. That's the whole part for this lab. And hi, let me ask whether my teammate still have something to say. Hi, Yuzhou. Do you still have something to say?
Oh, that's all for our lab.
Okay.
Thank you.
Good. So that's all for Lab 9. Thank you.